promise both of us can do it because you still need one more.
Okay, come on.
There's gonna be two of them.
Alright, this is our team.
Hey, how long is this gonna be?
I can make it,
Depends
you
on how
can
long
make it
you
short as
want.
you want it to be.
Done.
Alright, go. Go.
I'm out.
Go to the start.
We just did.
Alright, go on.
This is our outline.
I'm just doing this part.
We're probably not gonna talk about the SSOC, step response, frequency response, or proportional only. But that's all in here. This is our schematic.
Closed?
Closed.
Yeah,
Whoa.
closed.
Keep in mind, that other team had open.
Yeah.
You got closed, good.
We got a lot more to work with.
Good. Yeah, that's nice.
Yeah, we split it up in four. Cooney had the bottom one there, 40 to 55. I had 55 to 70. Walt had 70 to 85, and Brock had 85 to 100.
All right, skip it.
This is a little different than Brock presented on this last week. It's a little bit different. We reviewed our numbers there. These are the numbers that we actually got, which is pretty close to what we got from modeling. Actually, is within one. So I think we got was 12 for ultimate modeling, and you can see the average there is 12. For a quarter, I think we had 6.7 for modeling. And those are all, they're all pretty close to what they should be this time.
You remember their SSOC was sort of linear, kind of linear. And look at this, the ultimate KC, all these things from root locus say there's hardly any difference between the whole thing. I mean, quarter to case, that's 8.3 down to 6.1. Those are about the same thing. Now, white, their SSOC was not linear. Do you remember that? Say yes.
Yes.
And they had real different KCUs between the upper section and lower section. Go ahead.
This is just an example.
The red one is your output.
What's that?
The red one is the output transfer.
Yeah, this will be the experiment 2.
Proportional.
Proportional, yeah.
Blue, yes. Got offset anymore?
Save it for the offset.
Yeah, it's where Walt thinks over.
My job.
Okay.
So this is the PI. You can.
Oh, what was KCU for the P only? 12, wasn't it? Well, look at this, it's down to 8.63.
And the
I
PI
don't like
dramatically.
3 significant figures, but that's what it gives us.
This is for TI at 12, by the way.
TI 12,
Really big one.
really big.
Actually, it's right around 12 times our TO. It was 4 times our,
Okay. 3 times, it was 4 times 3 times.
4 times our 3 times.
So this is the ultimate quarter, 10, 50, 500s, and the critical is 1. And these are the stuff we use to find it on the tables and stuff we have. So these are the results for the my special little thingy here. You can see for the yeah. I'm talking to the board. You can come on back. The three.
Stand over here in the middle of the screen.
Is this
Turn
better?
around facing board. Can you see it now?
Yes.
All right. For this, that's the 3, and then the 3.197 is the 3.33 times Q0. So you did get a difference numbers here. But it turns out the ultimate right here is actually going to be exactly the same. So if you use 3 or 3.33, John, and you watch it, look at this.
Chuck, anybody.
Alright? It's the exact same. It's same, the quarter, is the KQD is the same, exactly. And everything else is there too. So, no difference if you use 3 or 3.33 times T0. And then this is the, back to the, did you go back?
I don't think so. Nope.
Oh. Well, it's the KCU at 8.6, TI 12, and this is the KCs in the settling time. See, this is offset right there.
Wait,
And for the KCU 8.6.
wait a minute, this PI controller?
Yeah.
Yes.
Hey, he's got offset for PI controller. Anybody have any opinion on that?
That's not good.
Positive.
Wait, it is for,
TI is just so high, I can't
I'm confused.
catch up. That's my theory.
See that there, I think.
Huge TI.
Huge. So this is my stuff for the TI 2.88 and TI 3.1968. And once again,
That's a fact.
once again, the KCs are exactly the same, but
Sorry, no.
the K ratios were different for the two, and the set times were very different using the two different approaches. So for the lower TI, you had a much lower set time. For the higher TI, you had a higher settling time. That.
Fantastic.
So these are the comparisons of the different, for the TI of 12 and the TI of 2.88 is in this one, and the TI of 3 is this one. So you can see the graphs are a little bit different as the TIs, as you change the TI. And this is all for a KC of 5.85, just changing the TI. And this is the valves open with a KC of 8.4 and a TI, comparing the two different TIs. And they're pretty much the same. This is supposed to be the wind up using the two different TIs, but they didn't really turn out what we expected them to. And we maxed it out, and it still didn't want to play nice. So this is what we got for the wind up for the two different TIs. And then the same for the wind down. It never like came back and then came back down like we saw the nice warning voltage before. So I just kind of wanted to stay there. So in conclusion, the experimental ended up being close to the root locus. We had small or no offsets, and then the PI, of course, is great. The lower TI is going to be better than the larger TI if you want a smaller cell.
It's like